This video is going to walk us through two complete solutions and then some other problems for using this stoichiometry map properly and identifying your givens and requireds and identifying your root. And then hopefully after that you will be fully confident in using this version of the map that has all your steps written in, and then you simply have to do the steps. And then I'd like you to move on to the other student guide that does not have the steps written in. You can use the one first that has the little symbols to remind you, balance, look for your givens and requireds, recall what you know, and then use the one that doesn't even have those right in your steps. And again, you really want to be solid on using this stoichiometry map. We're going to use it in the remainder of the course in the next 2 units. It only gets more complicated and there's another step coming. So please practice, actually write out your steps, because if you write step 1, balance equation, you're going to remember if you've done that a few times, and then you won't forget that step, which would mess up everything and result in great confusion. So please practice that way. So the first problem we're going to look at is this one. We're going to look at some of the terminology that gets used in the written problems as well. So you might need a bigger screen to make sure that you can see this, but I'll read it out to you as well. So the first one is, how many grams of hydrogen are needed to react completely with 50 grams of nitrogen? So again, this wording, react completely, it just means figure out your balanced chemical equation. If you're given so many grams of hydrogen, how many grams of nitrogen are going to react with it in the balanced ratio? So that's all it means. You can just ignore the react completely after you've read it and just pull out your given and your required. All right, let's take a look at that. What is our given and our required? Our first step, checking out that equation. And the question is it balanced as it's given to you? And the answer, very quickly you see, is no. So step 1, get the balancing done in there. Step 2, figure out your given and required. So for this problem, they have given you 50 grams of nitrogen. So that's your given. What's your required? Well, they want to know how many grams of hydrogen. So we're looking at our nitrogen and our hydrogen. And for step A, we're just ignoring the ammonia. We don't even need to think about it. We just need to figure out the two quantities, the two particles that the question is asking about. So we've got that, our nitrogen and our hydrogen. Step 3, recall known values, right? Because it's not in here. There's no molar mass given. Avogadro's number isn't given. So we need to figure out our molar mass. If this was simply written and you didn't have the equation at all, you would be expected to remember that both hydrogen and nitrogen are the Hofbrinkels. They come as diatomic molecules. So you would need to have 2 times the mass of the nitrogen atom for the molar mass of nitrogen, and 2 times the mass of the hydrogen atom for the molar mass of hydrogen. And we always want to remember that we know Avogadro's number. You don't always have to write it out, but I'd put a little NA as the reminder that you know that number. All right, so we are ready to solve this problem. We are starting from a given mass. We've got our 50 grams. Oh, sorry, that's not what I want to do. I want to just use the orange to say we're starting from the mass. We always have to go this way, then we have to go this way, and then where do we want to get to? Well, in this case, they are requiring the mass. This is a mass-to-mass problem, and I'll use the black so you can read it a little bit better. So we've got our 50 grams of our nitrogen. We need to convert to the moles, so we're going to divide by the molar mass of 28 grams per mole. Okay, and if you have this printed off, it can remind you of all of your equations, right? So we've got moles is mass, which we pull from there, divided by the molar mass is going to give us our moles. All right, so divide by the 28 grams, we're going to get 1.8 moles. And this is our given, so this is of N2. We can write a little reminder in there if we're not working on the map. You might want to write a little reminder of what species it is. So it's just the N2. Now we need to convert through our molar ratio. So back to our balanced chemical equation, we have 3 hydrogens for every 1 nitrogen. So it is 1.8 times 3, and then just divided by 1, so that does nothing. We are going to get 5.4 moles, and again, keep track of what you're doing. So you could write right under here what the required is. So bracket in that this is hydrogen, bracket in that's all nitrogen, whatever works for you. We're working with hydrogen at this point. And now where do we need to go? Well, follow our little map. We are going up to mass. That's what the equation asked for. So we need to multiply by the molar mass of our required in this case. So 2.02 grams per mole. We're going to multiply 5.4 times 2.2, and we're going to end up with 10.8 grams. And again, this is hydrogen, so you'll want to do a little therefore statement. So therefore 50 grams of N2 reacts with 10.8 grams of hydrogen. All right, and that is the end of that problem. Now, if you remember, just give you a minute to take a look at that. Okay, and you can pause when you come to this point in the video if you